Good morning students, welcome to another session of physics class. Today we are going to study one of the form of energy, that is mechanical energy. So what is mechanical energy? Mechanical energy is the sum of kinetic energy and potential energy. What is mechanical energy? It is the sum of kinetic energy and potential energy. So we can write mechanical energy is equal to kinetic energy plus potential energy. So today we are going to study about kinetic energy and potential energy separately. So first one we will study about kinetic energy. So suppose an object is moving. Suppose an object is moving. So what type of energy is possessed by that object? That energy is what? Kinetic energy. So the energy possessed by a body in motion is called what? Kinetic energy. So the energy possessed by a body in motion is called kinetic energy. So if you are moving, that time you are having what? Kinetic energy. If you are rolling a ball, then the ball is having kinetic energy. Now when an object is moving, it can do work. So an object can do work when it is moving, and the work done will be according to their velocity. So an object moving faster can do more work than an identical object moving relatively slow. So as the velocity increases, what will also increase? The work done also will be increasing. So as the body is moving faster, the work done also will be more. So when it is moving faster, it can apply more force. So what will happen? The work done will increase, and the displacement also will be more. So the work done will be more. So an object moving faster can do more work than an identical object moving relatively slow. So we can also say that kinetic energy of a body with certain velocity is equal to the work done on it to make it acquire that velocity. So what we can say, we can define kinetic energy of a moving body with certain velocity is equal to the work done on it to make it acquire that velocity. So if a body is moving with a certain velocity, then we can say the kinetic energy is equal to the work done on the body to make it acquire that velocity, that certain velocity. So hope you understood what do you mean by kinetic energy. Simply what we have to write, the energy possessed by a body in motion, or the energy possessed by a moving body is called what? Kinetic energy. Now we will go for the derivation of the equation for kinetic energy. So we have the equation to find kinetic energy. Ke is equal to half mv square. For this, what we have to do is, we have to consider an object of mass m is moving with a uniform velocity u. Now let it be displaced through a distance s when a constant force F act on it in the direction of its displacement. So what we have to do, we have to consider a object of mass m is moving with a uniform velocity u, and now we will consider that it is displaced through a distance s when a constant force of F is acting on the body in the direction of its displacement. Now we know that when force and displacement is there, work is done. So how can we find work done? We can find work done by the equation W is equal to F dot S. So we can find the work done on this body, W is equal to F dot S. Now this is equation number 1. Now the work done on the object will cause a change in its velocity. As the force is applied, what will happen? There will be a change in velocity. So the body was initially moving with a uniform velocity u. Now we are applying a force F. That when we are applying a force F, the body is displaced by a distance s. So work done is equal to F into S. Now as we are applying the force, what will happen? The velocity of the body will change. So now let us imagine that the velocity will change from u to v, small letter u to v. So that means u is the initial velocity and v is the final velocity. And as there is change in velocity, there will be an acceleration produced, and let that acceleration produced be denoted as a. Now from the equations of motion, we know that v square minus u square equal to 2as. So from the equations of motion, we know that v square minus u square equal to 2as. In the earlier part also I said, whatever we have studied in the other chapter, that we have to apply in all these chapters. All the 4 chapters we are studying, they are interrelated. So if you are not knowing the equations or definitions in the other chapter, it will be very difficult for you. So hope you remember this equation. We are having 3 equations of motion. In that one equation is that v square minus u square equal to 2as. So now from this equation, what we will do is we will take the value of s. We will take the value of s. So from here 2as, we will take 2a to the other side. So we will have the equation s equal to v square minus u square divided by 2a. So we can write the equation. From this equation v square minus u square equal to 2as, we will rearrange the equation and find the value of s, and we will get s is equal to v square minus u square by 2a. So we are just simply taking 2a to the other side. So it will become divided by 2a. So we are having the equation s equal to v square minus u square by 2a. This is equation number 3. Now we know that F is equal to mass into acceleration. So we know that F is equal to ma. So we can write work done as F is equal to, W, instead of F, what we will do? We will write ma. What we will write? Instead of F, what we will write? We will write ma, and instead of S, we will write the equation we have got earlier, that is s equal to v square minus u square by 2a. That equation what we will do? We will write right here. So w is equal to, instead of f, we are writing ma, into, instead of s, we are writing v square minus u square by 2a. When we are rearranging, what we will get? This a and a will cancel, a and a will cancel. So we will get this 2, 1 by 2 we will take outside. So w is equal to half m into v square minus u square. So instead of f, we have written ma, into s, we have written v square minus u square by 2a. Then what we will do? A and a we will cancel. This 2 we will take outside, so it will become 1 by 2. So w is equal to half m into v square minus u square. So half of our work is done. Now if the object is starting from its stationary position, then u equal to 0. So if the object was at rest in the initial position, then the initial velocity will become 0. So what we can do? We can, instead of u, we can substitute 0. So we will get the equation w equal to half mv square. So we are assuming that now the body started its motion from rest. That time the initial velocity will become 0, that is u equal to 0. Then we can write the equation w is equal to half mv square. Now it is clear that the work done is equal to the change in kinetic energy of an object. So from here we can say that the work done is equal to change in kinetic energy of the object. If u is equal to 0, then work done will be equal to half mv square. Now if your u is equal to 0, then what will be work done? Work done will be half mv square. Thus kinetic energy possessed by the body of mass m and moving with a uniform velocity v is given as pe or ek. Whatever you want, you can write. So you can write ek equal to half mv square. So here the work done is equal to the kinetic energy of the body. So we are writing, instead of work w, we are substituting it by ek, or if you want you can write pe is equal to half mv square. So this is how we are deriving the equation ek is equal to half mv square or pe equal to not PE, KE is equal to half mv square. So once again we will derive this equation. For deriving this equation, what we have to do? First we have to consider a body of mass is moving with a uniform velocity u. Then we are assuming that it is displaced by a distance s when a constant force of F is acting on it in the direction of its displacement. We already know that work done W is equal to F into S. Then we know that when we are applying a force, then the work is done, and due to that the velocity will change. Now the velocity changes from initial velocity u to final velocity v. Due to there is change in velocity, what will also be produced? The acceleration will also be produced. So that acceleration is we are representing by a. Now from the equations of motions, we know that v square minus u square equal to 2as. From here what we are doing, we are finding the value of s, and we get the value of s as s equal to v square minus u square by 2a. Now in this first equation, instead of s, what we will do? We will substitute this value v square minus u square by 2a. Before that we know that F is equal to ma, mass into acceleration. So what we are doing now, we are substituting the value of F and S in the equation. W is equal to F into S. So W is equal to ma into v square minus u square by 2a we will get. Or what we can write? We can write, after cancelling in acceleration and taking out the 2 from 1 by 2 from the bracket, we can write W is equal to half m into v square minus u square. Now we are supposing that the body or the object was initially at rest. From that rest it started its motion. So the initial velocity u will become 0. Then we can write W is equal to half mv square. Now here the work done is equal to the change in kinetic energy of object. So when u is equal to 0, then the work done will become half mv square. Thus the kinetic energy possessed by an object of mass m and moving with a uniform velocity v is given as what? Given as Ek or Ke is equal to half mv square. So this is the way we are deriving the equation for kinetic energy. Now we have potential energy. So what do you mean by potential energy? So as kinetic energy was the energy possessed by a moving object. Now what will be potential energy? It will be the energy possessed by a body at rest or a stationary object. The energy possessed by a stationary object will be what? Potential energy. So we can clearly define it as the energy possessed by the body due to its change in position or shape or configuration is called the potential energy. So the energy possessed by a body due to its change in position or shape is called potential energy. Now here you can see a rock on a edge of the cliff. So that is in rest. So this rock is having a potential energy due to its change in position or due to the position of the object. Now if you are keeping a book on the table, that book is having potential energy due to the change in position or due to the position of the object. So here these are the examples for the potential energy possessed due to position. Now due to shape. Now here when you are stretching the elastic string in a bow, what you are doing? When you are stretching the bow string is getting what? Potential energy due to change in its shape. The string is getting the potential energy due to change in its shape or configuration. Or if you are compressing a balloon, when you are compressing a inflated balloon, what will happen? It will get compressed. When you release it, it will come back to its original position. When it is in the compressed form, it is having a potential energy. Now when you are stretching a rubber band, what you will store? You will store a potential energy. So most of the time in the class you may be playing with the rubber band and a paper, isn't it? So you are using the paper piece as the bullet, and what you are doing, you are stretching the rubber band. So what will happen, when you are stretching more potential energy will be stored in the rubber band, and when you release it, when you are releasing the rubber band, the potential energy stored in that rubber band will be transferred to what? To that paper bullet, and the paper, as you are increasing stretching more and more, what the paper bullet will do, it will travel a more distance. That means you are storing potential energy. Due to that potential energy, what is moving? The paper bullet is moving. That means their work is done. Now a spring. In the spring also, what is most of the toys and all, what is there? Spring is there. So when you are turning the spring, what you are doing, you are compressing the spring. You are compressing the spring so that the potential energy is stored in that. When you are releasing it, what will happen? That potential energy will change into kinetic energy and will make the toy to move. That means there also work is done. So energy possessed by a body due to its change in position or shape is called what? Potential energy. So the examples of potential energy due to change in position is a rock sitting on the edge of a cliff, or a book kept on the table, or a certain object at a certain height. Then the examples for the potential energy due to shape is stretched bow, or is compressed spring, or a compressed balloon, or maybe a stretched rubber band are the examples for the potential energy due to change in shape or configuration. So hope you understood what is potential energy. Now we will learn how to potential energy of an object at a height. Now an object increases its energy when raised through a height. This is because work is done on it against gravity while it is being raised. Now the potential energy of an object at a height increases as we are increasing the height. So this is why, because we are doing a work against the gravity. The energy present in such an object is called what? Gravitational potential energy. So when we are raising an object to a certain height, there what energy is stored? Gravitational potential energy is stored. So the gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to the point against the gravity. So what is gravitational potential energy? It is defined as the work done in raising it from the ground to a point against the gravity. Now we will have the derivation of the equation potential energy PE is equal to mgh. For this we are considering an object of mass. Let it be raised to an height h. So here one object is there. So it is having a mass of m, and we are raising it to a height of h. Then a force is required to do this. For when we are raising it, what is needed? A force is required to raise the object, and the minimum force required to raise the object is equal to the weight of the object mg. Now for raising this, the minimum force we are applying is equal to the weight of the object, that is equal to mg. Now the object gains energy equal to the work done on it. Now when we are raising the object, it will get an energy which will be equal to the work done on it. Let the work done on the object against gravity equal to work done equal to force into displacement. Here force is the weight of the object and displacement is the height through which we raise. So we will write mg into h. So work done equal to force into displacement, which is equal to mg into h. So when we are combining, we will get work done equal to mgh. Now since the work done on the object is equal to mgh, and energy equal to mgh unit is gained by the object. So when here for raising the object, what we are using an work done, the work done is equal to mgh. So what is required, since the work done on the object is equal to mgh, and an energy equal to mgh unit is gained by the object, and this is the potential energy Pe of the object. So this is the energy acquired by that object after raising is known as the potential energy of the object, and the equation for finding potential energy P is equal to mgh. Now here the work done by the gravity depends on the difference in vertical height of the initial position of the object and not the path along the object. So here the work done by the gravity depends on the difference in the vertical height of initial position and the final position. Sorry, here I have not written final position, so you can include that also. Initial position and the final position of object, and not the path along with the object move. So here we are considering only the initial position and final position. What is work done is equal to force into displacement, and displacement only depends upon the initial and final position, not on the path. So here if whatever the path may be, it will be only depend upon the potential energy, will only depend upon the displacement, that is initial and final position. So what we will get potential energy is equal to mgh. Hope you understood. If you are having any doubt, you can call me and ask me, or if you want, you can WhatsApp me also. Your doubts will be cleared.